Hello and welcome back to another episode of Game Dev Security. In this episode, we're going to talk about how we can make sure the data sent from the game to our server has not been tampered with. This is loosely known as certificate pinning, and we're going to do something similar. Just to give a little bit of background on certificate pinning, when a client connects to a server, as you probably know, it connects over SSL to make sure no man in the middle can monitor the traffic and alter it or intercept it. It basically encrypts the data. However, it doesn't really stop the attack if the attacker is actually the user, because what the user can do is the user can tell their phone or client to use a different SSL certificate. So they could supply the SSL certificate and then they would be able to encrypt and read any traffic which is sent to their server. And this is kind of a common problem in gaming, especially in financial apps. So how this is generally solved, it's kind of solved with what's called certificate pinning, where you basically tell the server and the phone to don't trust any SSL certificate, only trust this SSL certificate. So only trust, the SSL certificate of, my game dev company. However, this is actually quite hard to do in Unity because Unity doesn't really have inbuilt functions for this. You have to build native libraries for iOS and Android. Also, I don't like certificate pinning too much because certificate pinning is more for the client to trust the server, so the client knows the request is coming from the server. However, it doesn't really help as much if for the server to trust the client, i.e. the server to know the data has come from the client and not somebody pretending to be the client. And that's really the issue in game dev. In other type of applications like banking applications, the issue is, do you know that when you connect to your banking application, do you know that the website you're getting is actually from your bank and not somebody altering the data in between? However, with game dev security, it's more, does the game dev know that the information is actually coming from the client? And certificate pinning, again, it's harder to do a few certain things, such as key rotation, which I'll talk to a little bit at the end. Anyway, that's certificate pinning. It's a deep subject, and you can you can do more research on this on your own time. However, what does this mean for us in our game? So we head over to our game. As I mentioned before, we're not going to do certificate pinning exactly. We're going to actually encrypt the data in the payload before we send it across with an encryption key, which is stored on the client and the server. So basically what this means is that the client will encrypt the data with an encryption key. One encryption key is shown here. And the server will decrypt it with the same encryption key. And then if the user tries to monitor their own data and change it, such as Daniel showed in Season 1, Episode 5, they won't be able to because it'll be encrypted. So let's look at that. Okay, so first thing to note is we have our encryption key here. Obviously, do not use this encryption key. Every game will have to have its own encryption key. Ideally, this is a little bit more advanced. You want to make an encryption key for every different user. That's probably an advanced subject from something for more for Game Dev Security Season 2. We'll look at some more advanced techniques you can do. But for now, we're just going to make an encryption key for our game. So there's some helper functions here. If I uncomment this, we can actually run this, and it will generate an encryption key we can copy and paste here and on our server. So we only have to run this once. So let me just run in the editor. And we've got a encryption key generated. And I'll paste this here. And we also need to paste it into our cloud script. And we need to save. Okay, so now we can actually uncomment this because we don't need to do it again. It's good to have it there in case you want to generate new encryption keys. As I said before, I'll talk about more of this at the end, but it's good to kind of rotate or change your encryption keys. Anyway, so now we use this class simple AES. This is a new file in the project. You don't need to really understand how this works. This just uses some C# encryption libraries to do our encryption. So now when we get the random nonce, we actually encrypt it, and then we send the encrypted version over to PlayFab. And then in PlayFab, if we go to our function, we can see that it retrieves the payload and it decrypts it. Yeah, so that's basically all we're doing. There's not too much to show here because the effect will look the same as the last video, but I can actually just show that if we go to our function, we can maybe just log this out. So just so you can see that an encrypted nonce is being shown each time. So we go here. So we can see that this is encrypted, where the nonce itself, if we go over to our nonce and debug that out, is very, very different. Yeah, so we can see here, this is a nonce and this is the encrypted version. Okay, so that's basically all to show there. So let's just talk a little bit more in depth about how we can use this in other features and actually how this works. So you can actually use this same encryption library to encrypt any data. It depends on your game. Say you want to send some sensitive data to the server that you would prefer the user wouldn't be able to see and change. You can just pass this string to it, pass the string to this, and it returns an encrypted string. And then on playfab, you can call the decrypt method there to decrypt it. Again, we are using it to make sure the nonce can't be tampered with, but you can use it for all sorts of type of data. I generally, my games, use this all the time because I just want to make it hard for any attacker. I just, it costs nothing to really use it. It's not very intense. It doesn't really affect the gameplay for frame rate or anything like that, so I use it a lot. However, you may have noticed this little ugly thing at the top here. And if we actually load our cloud script, it's starting to complain. It's starting to say the cloud script revision is very large. And that's because playfab cloud script is quite limited. It doesn't really give us native encryption and cryptographic functions. So we basically have to import them. And the way I've imported it here is it looks ugly, but it's the cleanest and easiest way to import it. You just copy and paste this at the top, and then we have access to this decrypt function. So if you wanted to use this in your own server, so this is specifically for Node.js, but if you wanted to use it on playfab Azure function, the actual code, which is kind of compiled, is probably not the right word, but the code that is here, the original code is actually here. So it uses the Node.js crypto library, and it mainly uses AES encryption or decryption here. It also does some other things. So you can actually use this on your own server. Again, I used a library called Browserify, which lets us compile it into something like this, which lets us import it for use on websites and playfab cloud script. Another thing to mention is that this encryption is only as secure as this key. So it is possible for the attacker to extract this key from the game, especially if they decompile the game. This is why we have obfuscated our game. So there was an episode on obfuscation. Salima talks about that a few episodes back, so please make sure you've watched all the videos to get an understanding of that. That makes it harder for them to see the key in the game if they basically decompile the game. A few things you can do to make it more secure is to split this string up. You basically split it into key 1, key 2, and then you basically just kind of key 1 has the first third of the key, key 2 has the second third, and key 3 has the final third. Then when you actually use the key, you combine them with a string concatenation. That way when you obfuscate it, it just makes the keys even more harder to find. And what I do in my games is I actually when I make an update to my game, I actually I change the key. It was known as key rotation, because eventually a determined hacker will get this key out, and once they've got the key, they are able to basically make fake requests. However, it's not easy for them to do that. So if you change the key regularly, they can only do that for so long, and then they have to do it again. Another thing to mention is this encryption method. It uses a static key, so it's the same key for all users on all games. at some point that's unavoidable. You need to do this. However, in some more advanced protocols, it's what I do in my games is I use a static key to make a request to the server for a user key, and then a user session key. So the data is encrypted with a temporary user session key, which is unique to that user and is only valid for 30 seconds. So then the attacker has to get that key and decompile the payload with that key, and also they have to get this key and decompile with that. Which has more work. That's a more advanced, but a bit more complicated protocol, but I'll probably talk about that in another more advanced lesson, probably in season 2. Anyway, just to summarize, this is one strategy that we can make sure, as best as we can, I would say make sure we can be more confident that the data that we are receiving on our server from a client is actually from the client and hasn't been altered or isn't from something pretending to be the client. So thank you for watching. I hope that was informative, and yep, as I mentioned before, I will put links to the various repos in the description, and I believe this code will be on security branch 3 or 4 of the Git repo. Again, I'll confirm that in the description. Anyway, thank you for watching, and see you next time.